Hi and Assalamualaikum. My name is Muhammad LUTFIL HADI bin Muhammad RIDUAN, MA 19300. We are from Group 4, Section 3 of Subject BMM3563 Finite Element Method. Now we want to present about our project. So these are my group members, EZZAT, EZZAT, and SYAHRIZAL. First of all, the finite element method is a numerical method for solving problems of engineering and mathematical physics. It is commonly used in structural analysis, heat transfer, fluid flow, mass transport, and also electromagnetic potential. So our group chooses a stapler for our project since pressure and forces are involved in using the stapler. Basically, it requires Autodesk Inventor Nastran software, sample model of a stapler, and also SolidWorks for the drawing.
Assalamualaikum and good day. My name is Muhammad Eizzat bin Muhammad ALIZA, Mature ADM A19301. I will explain for the part 1, which are base unit. So this is for the base unit for the stapler. For the volume stress, for the maximum value is right there, and for the minimum value is at the hole. Next, for the solid effective strain, for the maximum value, they also right there, and for the minimum value also at the hole. Next, for the displacement, the place was be taken at the bottom of the base unit, and for the minimum value is 0. That's all from me. Thank you.
Good day and salam Jatra. My name is THIRUVICKNES of MOHAMAD and I am this MA 19264. So continuing to our step analysis, my part is the post process. So for post process, we have volume stresses. Volume stresses is a value used to determine the given material in the yield of nature. It is mostly used for ductile material such as metals. The volume is here written text that if the volume stresses of a material under load is equal or greater than the yield limit of the same material. So volume stress called the estimate utilizer to decide in the event that is applicated or break. So stress and strain in the 3D can in a variety of directions. So for the next is the 6 stepper parts as well as deformer total. So firstly is the one resistance of the base unit part. Then we have one resistance minimum maximum value and deformer total. Then we have part 2 is the maximum carrier and one resistance is minimum maximum value and deformer total. So continuing we have part 3 cover holder, and part 4 we have the steel top. Part 5 is the handle. Part 6 for top housing. So then we have solid effective strain. Solid effective strain we use is the elastic. It's a solid element effective strain. When the material is pressed, it experiences strain. When the tension is nil, the strain is referred to as elastic. The stretching of the material's bones causes this form of strain. Furthermore, when the material is actually yielding, that is when the state of stress is on the yield surface, effective strain develops. So same as the one stresses, we have part 1 for the base unit, solid effective strain base unit, then solid effective strain minimum value and deformer total. For deformer total, all the parts are same as one stresses also. Then we have part 2 maximum carrier, part 3 for cover holder, part 4 is stop, part 5 is standard, part 6 stop housing. So continuing the displacement, the basic objective of the displacement based finite element method is to compute the displacement variant with a solid subjected to external force. To make this precise, we should use a solid development under the external loads. Every point in the solid moves as the load supply. So same as part strain and one is the deform total is the same value for one and strain. So part 1, part 2, we have part 3, part 4, and part 5. Part 6, okay. The deform total is changed a bit from the one and strain. So then we have mesh components. So this part tells about the composition of the subpart from all parts that follow elements at the corner of each element is unknown. This type of mesh is depending on the property definition of material. It is not related to control over the element size, element order, and order dependent. So this is the basic parts for the part, which we have for part 5, and we have more congruence plots and deformer total. Then the improvement part for mesh congruence. So for the mesh improvement part is part 1, congruence plot, deformer total. Then we have part 2 for congruence plot and deformer total. So that's all from my part. Thank you.
My name Muhammad Eizzat bin Zaherruddin, matrix number MA19259. I will present about discussion and improvement. To begin with discussion, elastic limit, upper and lower yield, and rupture stress are the three parts of the stress strain that can be evaluated during the finite element analysis. The analysis limit is the point at which no energy is wasted during the stressing and straining process. Processes that do not exceed the elastic limit, in other words, are reversible. Above that point, the deformation become plastic rather than elastic, and there is an irreversible component to the deformation. Lastly, the separation of an object induced by stress is known as a rupture or fracture. As the material thins, more pressure is applied until it snaps at the rupture stress point. Then we continue to improvement. We can see from this slide there are the view of the improved design and the drawing of improved design with different dimensions. This has been improvised at its material where it made up from metal and hard plastics. Applied force will decrease use from the old design. Last one, the design is very easy to handle and use it.
Assalamualaikum and hi, I'm SYAHRIZAL. In conclusion, from this experiment, all type of product or parts has their own ability, as we know that every difference such as material, sizing and dimension will give a different result. The operation of a model in terms of time or space, which aids in the examination of the performance of an existing or proposed system, is known as simulation of a system. In other words, simulation is the practice of utilizing a model to study the performance of a system. It's when you use a model to simulate something. Nonlinear behaviors include displacements that cause loads to change their distribution or amplitude, materials that change properties as they are loaded, and gaps that open or shut. The third point is the von Mises stress is a measurement that can be used to evaluate if a material will yield or fracture. It's mostly used on ductile materials. Body in an initial state of equilibrium or a deformed state is subjected to a body force or a subject force. The body deforms to a new state of mechanical equilibrium or deformed state. The inner body forces are caused by a force field like gravity, but the surface forces are caused by forces applied to the skin. That's